When we set up content-based routing in the last module, we were depending on the services of a pipeline. If we had not configured our receive location with the correct receive pipeline, our application would not have worked. But we've more or less been treating pipelines as a black box. So let's start off this module by looking at what goes on inside of a pipeline, and then we'll take a look at what they consist of. And then I'll talk about how you can extend the functionality of pipelines to implement new features. After that, we'll talk about the practical implications of creating pipelines of your own, and I'll show you how to do that. And then I'll show you some tools that are available to you that you can use to test your pipelines. In the first lesson of this module, I am going to spend a few minutes describing exactly what a pipeline is and how you can use them. And then I'll show you how pipelines are structured. I'll show you some of the built-in features of the pipelines that come with BizTalk. And then I'll end this lesson by talking about what it takes to add new features of your own to BizTalk pipelines. Alright, to put first things first, what exactly is a BizTalk pipeline? Well, in short, a pipeline is a set of components that process a message as it enters or exits BizTalk. The pipeline object itself is just a container of configuration settings. So we saw that when we were configuring ports. Ports were just containers of configuration settings. And likewise, when receive ports, we had receive locations. Those also were containers of configuration settings. But those referenced components that actually did the work. In the case of a receive location, it's an adapter and a pipeline. So in that vein, a pipeline is a configuration object that references a collection of components that work together to process a message as it enters or exits BizTalk. So if we look from the perspective of a receive port, a pipeline in a receive location is going to be receiving a stream of bytes from its adapter. Each component in the pipeline is going to play a role. As a component completes processing the collection of bytes that it has received so far, it is going to pass those on to the next component in line, and the first component is going to be ready to accept more data from the stream. So rather than read in the entire content of a message before they process it, these components process messages as streams for the sake of efficiency. They can make much better use of resources by implementing streaming behavior. So these components all work together to process a message as it's passing through. They're all ordered in a well-defined sequence so that as the output of one component is passed to the next, we know that it will have what it needs to do its processing. Once the last component of a pipeline in a receive port has completed its processing, that stream of bytes will be sent to one of two places. It will either be published directly to the message box, or if that stream of bytes represents an XML document, and there is a corresponding map configured in this receive port, in that case, the byte stream will be handed off to be processed by a map before it's sent to the message box. In a send port, this would all be reversed. The stream of bytes would be delivered by the message box to the pipeline. The pipeline would do its processing and send those to the adapter, which would take care of transmitting the message out. So having said all of that, what can we do with pipelines? I mentioned that pipelines provide the ability to debatch messages and create batches, and that we can use them to convert from flat file format to XML and vice versa. It's not too hard to think of other scenarios in which you can apply pipelines. For example, you might be reading an encrypted file from an FTP location from a trading partner site. And if your internal systems don't understand that encryption format, you might think about applying a pipeline to decrypt those messages before they're published to the message box. Now perhaps it turns out that that message contains an XML document. You might want to check that XML document to see if it contains valid data. So you might think about configuring a pipeline to do both of those things. It could decrypt the message and then validate the XML against a schema as it's publishing that document to the message box. On top of all that, perhaps that message is even digitally signed. And in that case, you might think about using that same pipeline to validate that digital signature and verify that you have a corresponding certificate installed in your environment. When you look inside a pipeline, you'll find that pipelines are organized into predefined stages. And each of these stages can contain 0 or more pipeline components. Now, the maximum number of components that is allowed at any point in a pipeline depends on the stage. And there are actually two different types of pipelines. We have receive pipelines and send pipelines, and the stages are different. A receive pipeline has the stages that you see listed here. Each of these stages then has been assigned a predefined execution mode. The components in a stage will execute in one of two different modes. One of those is called first match mode, and only one component will execute in that stage. It's the first one that knows how to process that message. And then the second execution mode is known as all mode, and as the name would indicate, all of the components in that stage will process the message, and they will process it in the sequence in which they are listed. Now there's actually only one stage that runs in first match mode, and that's the disassemble stage. And that's the stage at which a message might be converted from a flat file format to XML. And there might even be some debatching that occurs as part of that conversion. On the other hand, we might have an XML document that contains a batch of messages. So it's possible then to include multiple components at the disassemble stage, each of which knows how to handle a different type of message. The way that works is that a pipeline that can run in the disassemble stage implements an interface named iProbeMessage. And then the BizTalk Pipeline Manager, which governs this whole process, will use that interface to pass a reference to the message to the first component in line. And that component will have a chance to start examining that message and determine whether or not it can process it. As soon as it reads in enough of the message to make a decision, it returns either true or false back to the Pipeline Manager. If it returns true, the Pipeline Manager turns around and makes another call to that component, telling it to process the message. And then the rest of the components in the disassemble stage are skipped. If, however, that component determines that it doesn't recognize it, it will return false back to the Pipeline Manager, and the Pipeline Manager will pass that reference to the message to the next component in line. And that process continues until a component indicates that it can process the message. Now, to look at the specifics of this receive pipeline diagram, you can see the 4 stages are decode, disassemble, validate, and resolve party. The first component in the decode stage is going to receive the raw bytes from the source, which is typically a receive adapter. So it would only make sense that these components need to know how to convert that raw stream of bytes into a message. So this is where decryption would occur, for example. And then after decoding, the message is passed off to the disassemble stage. When we add promoted property information to a schema, we are providing instructions to a pipeline component that will execute in the disassemble stage and read those values out of the message that it's processing and add them to the message context. So once the disassembler has completed its job, and if we have a component that can validate the message, the pipeline manager will then pass the message stream to the first validation component. And then when the validation components have completed their task, processing continues on to the resolve party stage. And it's at that point that we might have a component that verifies a digital signature. And once the last component in the resolve party stage has completed processing, the message is either sent to the message box or it's sent to be transformed by a map. The send pipeline then is organized into 3 stages. And that makes sense. There is no need for a validate stage. Our application is producing the message, so it better be valid. And there's no need for a resolve party stage, since BizTalk knows that it's our application sending this message. And so in lieu of those 2 stages, we have a pre-assemble stage, and that's just there to leave the option open for any custom components that might need to execute before the assemble stage. None of the built-in components make use of the pre-assemble stage. Then we have the assemble stage, and this is where batches can be combined. Now, it would be really nice if you could configure one of these send pipelines in a send port and let it take care of assembling this batch of messages, but unfortunately it's not that simple, so you need to write some custom code to handle that situation. You would add that custom code to an orchestration to create an instance of your send pipeline, and then you would feed the individual messages to the send pipeline. And then your custom code would need to extract the batch message on the output side. And then from there, the batch message could be sent out through a send port. And then finally, you have the encode stage, and that's where you might do something like encryption. Okay, well that's enough about how pipeline components are organized. Let's talk about the components themselves. So a pipeline component implements some particular operation that can be applied to a message. And so a component is going to receive a stream of bytes that represents the message, and it's going to produce a new stream of bytes that represent the message after the component has completed its action. And it will also have access to the message's context properties. So it might read from that collection of properties, or it might write to that collection of properties, adding new ones if need be. And then BizTalk gives you a collection of these components built into the installation, and they meet the common needs of most applications. If your application requires some additional functionality in a pipeline component, it's possible to create your own. I'll talk about that in a few minutes. So let's look at what's available before we talk about custom components. One of the most commonly used components is the XML disassembler. And this is the component that can be used to debatch XML documents. So we could have an XML document that represents some sort of an envelope, and it contains many smaller documents within it. We can set up a schema with the rules to debatch those smaller documents, and then we can rely on the XML disassembler to carry out those rules. But even more commonly, many applications rely on the XML disassembler to read those property promotion rules out of schemas, and then the XML disassembler will perform those promotions at runtime. When a property is promoted in a schema, an XML annotation is added to describe that promotion, and that annotation includes an XPath statement that indicates how to find the field within the XML to extract the value that needs to be promoted. So the XML disassembler will read that XPath statement, and it will watch for that node to pass by, and when it sees it, it will read that value and write that to the message context. One of the other things that the XML disassembler does for XML messages is it determines the message type. When the XML disassembler receives a message, it is going to read the root node of that message, and then it is going to look at the XML namespace for that root node, and it's going to concatenate a string consisting of the XML namespace, a hash character, and the name of the root node. And then it's going to perform a lookup against all of the schemas that have been deployed to BizTalk. And it can load that schema and use it. And that's how it can find the property promotion instructions for a particular message type. If it doesn't find a corresponding schema, by the way, it will report an error and that message will be suspended. But if that's not the behavior you want, you can configure the XML disassembler to accept unrecognized messages. It just won't be able to do any sort of schema processing. It's also possible to enable XML validation on the XML disassembler. Even though there's a separate validation stage and a separate validation component, you can enable this on the XML disassembler itself. And that's disabled by default for performance reasons. Now the equivalent send side component, known as the XML assembler, can be used for property demotion, and that is in which the value of a message context property is read and then it's inserted into the body of a document. It can also be used to wrap a batch of messages in an envelope. Like I mentioned before, that needs to be implemented with custom code, but you can find an SDK example that does that type of batching. A thing to note here, a lot of people assume that if a send port is transmitting XML, that it must be configured with a pipeline that includes this XML assembler component, and that's actually not the case. If you're not making use of this property demotion or envelope and batching capability, then you don't need to be concerned with the XML assembler component. The flat file disassembler and assembler components provide much of the same functionality as their XML counterparts. They can perform property promotion and demotion, they can perform debatching and batching, and of course they can convert from flat file format to XML and vice versa. So if you're going to use one of these components, you need to configure it with a schema that contains the flat file conversion instructions. And then it will read that schema and it will pull out all of those parsing details from the various XML annotations. And that's how it knows how to perform the conversions. Sometimes people use the built-in flat file disassembler as a starting point for creating a custom disassembler. BizTalk provides an XML validation component that is separate from the XML disassembler. And of course, the easiest way to get validation is to simply enable it on the XML disassembler. However, there are still a few uses for the XML validator. For one thing, you can use it to validate the output of the flat file disassembler. So even if you are receiving XML messages, you might want to bypass validation in the XML disassembler, and you might want to configure the XML validator component with an alternate schema that's not as stringent as the one that the XML disassembler would use. Maybe there are only certain critical fields that you want to watch closely, and the rest of them you'll accept as is. The XML validator will stop processing as soon as it encounters one validation error. The document might contain more, but it will only report that first one. There are a pair of components for performing MIME and SMIME encoding and decoding, and that was originally paired with the SMTP adapter in Visual Studio 2004, but that capability is now built into the SMTP adapter. But you can still use the send side component to encrypt messages, and it can be used on the receive side to check for digital signatures and to decrypt the message. Just be aware that when it's validating those digital signatures, it will be using certificates that it takes from the local store on the machine that's hosting the adapter. The party resolution component determines who is submitting a message to a receive location based on certificates or on Windows identity. And it's used to identify roles for orchestration, and we're going to talk about that later. It requires its host to be authentication trusted, and it serves as a key component for enforcing the security boundaries on the receive side. Ports can be configured to drop messages if the party resolution component indicates that it doesn't recognize the sender. In the second part, I will show you how to create pipelines that use those components. You'll be able to pick and choose which components are required to process the messages for your application. But that's not always necessary because BizTalk provides some built-in pipelines. There are two so-called pass-through pipelines, and these are minimal pipelines. They actually don't contain any components. There is a pass-through receive pipeline and a pass-through send pipeline. So if you have a receive location that doesn't need to do any pre-processing of a message, or you have a send port that doesn't need to do any post-processing, you can make use of these pipelines. If, on the other hand, your receive location is going to be accepting XML messages and you need to do property promotion, you can use the XML receive pipeline. The XML receive pipeline includes the XML disassembler and the party resolution component. It does not include any components in the decoding or validation stage. On the send side, you can use the XML transmit pipeline, and that simply includes the XML assembler component. You'll want to configure this pipeline in your send port if you want to use the property demotion features. And as I mentioned, if your send port is transmitting an XML message, it does not necessarily need to use this pipeline. If the message is already in the format required by the destination system, then this pipeline would really only be performing unnecessary processing. If none of the built-in components meet the needs of your application, it's always possible to create custom pipeline components. So you might create a custom pipeline component to handle some of the situations that are described here. For example, validating a file format that is not XML. Or maybe you need to support an encryption or decryption algorithm. Or maybe you need to implement some form of data conversion. And sometimes it makes sense to create a component simply to promote a particular property. And that can be useful when you don't have the benefit of a schema to define your property promotion rules. If your application is handling some form of binary files, for example, you might be able to read some form of metadata out of that binary file as it's passing through the pipeline. And you might want to promote values taken from that metadata into the message context property. So something like a JPEG file. So it really depends on the needs of your application whether or not it would make sense. So what does it take to create one of these custom pipeline components? They fall into three different categories. There is just a general category. These would be components that are doing something like encoding or validating. And then there are assembling components that take individual messages and batch them into an envelope. And then you can create disassembly components that perform custom debatching. You can find an example of a custom pipeline component in the BizTalk SDK, but I'll give you an overview here so you'll have some sense of what it involves. You can get started writing a new custom pipeline component by creating a new class library project in Visual Studio. And then you need to mark your class with a .NET attribute called component category. And then BizTalk will be able to recognize your class as a pipeline component. You can also use that component category attribute to specify in which stage this pipeline component can execute. Then your class will need to implement the four interfaces listed here. The I-base component simply provides some simple properties that include the name, the description, and the version of this pipeline component. And then the I-component UI interface implements some design time capabilities. You can use it to provide a custom icon that will show up in the pipeline designer. You can also provide some designer validation code that can check the configuration settings that have been applied to your component. You'll also need to implement the iPersist property bag interface, and that's what allows your component to store and retrieve configuration settings. Finally, you'll need to implement the iComponent interface, and that has a single method on it called execute, and that's where the actual work gets done. There is one other interface that isn't listed here, but it's required only for disassembler components, and that is the iProbe message interface that allows a disassembler component to inspect a message to determine whether or not it can process it. Now, it is possible to modify a message within a pipeline component, but you really need to handle messages with care. After all, BizTalk generally considers messages to be immutable. If your iComponent execute method is simply promoting properties, such as the code that you see on this slide, you can perform that promotion on the original message that your component received. If, however, you need to alter the contents of the message that your component received, you'll actually need to clone that message. Then you can make changes to the cloned copy. When you clone that message, you'll need to copy over the existing message, its parts, and the message context. When you're writing your execute method, you'll be able to access a helper object known as the pipeline context. And the pipeline context provides details about where your component is in the pipeline. And it provides methods to access schema information. And it also provides access to a message factory object. And you can use that message factory object to create new messages, new message parts, new context properties, and so forth. Just be aware that the pipeline context is a different object than the message context. The lines of code that you see on this slide are accessing message context properties. So once you've completed implementing your execute method, then you will need to compile and deploy your assembly, and you can do that in one of two ways. You can copy your class library assembly into the pipeline components folder that's beneath the BizTalk installation directory, or you can install it to the GAC. Copying it to the pipelines folder is generally just done for development purposes because that's where Visual Studio looks when it's populating its toolbox of pipeline components. In general, it's a better idea to deploy all of your custom components to the GAC. Now, fortunately, it's actually pretty straightforward to put a pipeline together. So if you are going to use the built-in components, or you have some custom components that are available, BizTalk makes it very easy to arrange those components in a pipeline and to configure them. So in this lesson, I'll walk you through the process of creating a pipeline using some of the components, and then you'll be able to create one in the lab, and you'll be able to create a pipeline that actually encrypts and decrypts data. The Pipeline Designer is by far the simplest of all of BizTalk's development tools. You can create a new pipeline simply by adding a new pipeline to your BizTalk project, and then dragging and dropping components from the toolbox onto the pipeline design surface. If you try to drag a component from the toolbox into a stage that is not valid for that component, the pipeline designer will prevent you from dropping it there. So you can drag components onto the design surface, arrange them in the various stages in the order in which they should execute. Now you probably want to follow a strategy in which you can create pipelines that you can reuse amongst many different receive locations. As you can see, the designer allows you to set the properties on individual components, but you can actually override those values at deployment time. So the values you enter here more or less just serve as defaults. So you probably just want to operate under the mindset that you're creating pipeline templates here that you're going to deploy out to your runtime environment. And then when you deploy your pipeline out to the BizTalk runtime environment and start configuring receive locations to use it, you can configure each particular instance of your pipeline to meet the needs of its receive location. So in other words, you can use the pipeline designer to define the structure of your custom pipeline. And then at deployment, you can use the administration console to configure the various instances of your pipeline. You're going to get a chance in the lab exercises to use the MIME SMIME encoder to encrypt data. So it's actually a very straightforward process to create the custom pipeline that uses this component. You just drag it onto the surface and set a couple of properties, and then you deploy it. The bulk of your work is going to be to install the certificates that it uses to actually perform the encoding. So this component was originally provided to work in concert with the SMTP adapter in BizTalk 2004, but the new SMTP adapter no longer needs the features of this component, but it's certainly a useful component in its own right. If your BizTalk application needs to handle flat files, you will need to configure the flat file disassembler with a set of schemas. You will always need to provide a schema that defines the body of the flat file, and that is where the disassembler expects to find the individual records that make up the flat file. But if your flat file includes header fields, you will need to configure the flat file disassembler with an additional schema that defines the format of those header fields. And then if your flat file includes trailer records, you'll need to configure the flat file disassembler with a trailer schema as well. Now, when either the XML disassembler or the flat file disassembler is going about its job debatching messages, it may encounter invalid records from time to time. Perhaps the XML disassembler debatches a message and discovers that the resulting message does not match any of the schemas that have been deployed to BizTalk. Or perhaps the flat file disassembler debatches a message and tries to promote a property field that doesn't exist. The normal behavior in these situations is that the entire batch of messages will be suspended in the message box. So even though there may have been hundreds of records and only 2 of them had errors, the entire batch will be suspended. For many applications, it would be perfectly acceptable if only those 2 invalid messages were suspended and all of the rest were allowed to continue processing. And so you can enable that type of behavior. So what you'll need to do is you'll need to locate the configuration settings for your disassembler component and enable a property called recoverable interchange processing. BizTalk uses the term interchange to describe a batch of messages. When you enable recoverable interchange processing on a disassembler component, that informs the component to extract the messages independently of one another. So when a message is extracted successfully, that one will be propagated on down the pipeline, and that message will pass through the message box without being suspended. And then when the disassembler encounters an error with a message, it will send that message to the message box, and it will be suspended resumable. Now be aware, if that message is resumed, it's going to be the exact same data that was submitted in the first place, so quite likely it will be suspended once again. Ultimately, it will be necessary to terminate the message, correct the data, and resubmit it through a receive location. On the other hand, a debatched message may have been suspended because no subscriber was found for that particular message. In that event, once the issue is resolved with the subscription, the message can be resumed and it will continue processing. Now, if you want to debatch XML messages, you need to indicate that in the message schema. There is a property that you can set on an XML schema, and it is called the envelope property. By default, that is going to be false, so the XML disassembler will not debatch. But if you change that property to true, then the XML disassembler will discover that. When it looks up the schema for an XML message and it finds that that schema has marked as an envelope, it will go about debatching the message. Now it needs one other piece of information in order to complete that task. So you need to provide an XPath statement. And you can do that by setting the body XPath property in the schema designer. And you don't actually need to write the XPath statement. The schema editor will provide a tree view of the schema, and you can navigate to that. And what you want to do is you want to find the node that defines the individual messages. If, for example, you want to debatch the individual items in a purchase order, you would navigate into the tree view and click on the immediate parent of the item element. So that might be something like items. So at runtime, the XML disassembler will evaluate that XPath statement, and it will iterate through each of the child nodes and create a new message out of each one. So there actually really is no configuration that you need to perform on the XML disassembler. All of the information that's required to perform the debatching is contained in the schema. If the XML disassembler sees that, it will make use of it and debatch. And this debatching capability is really useful, particularly when you start working with orchestrations. You'll find that orchestrations are really intended to work with individual records. And one of the big advantages of debatching messages is that BizTalk can process those in parallel. So if you have multiple servers on a farm that are configured to run an orchestration that processes these messages, BizTalk can distribute those messages across the various servers in the farm, and then they can be processed in parallel. Since so much of the work that you need to do to implement disassembly is actually done in the schemas, and it would be kind of tedious to keep redeploying to the runtime environment just to test simple schema changes, BizTalk provides a set of command line tools that you can use to test your disassembly schemas. These tools simulate the flat file and XML disassemblers, and you run these tools from the command line, providing the names of the schemas that you're testing, and then you also provide the name of a file that contains your test data. So there is a tool to test your flat file disassembly, and you can also test the reverse operation, flat file assembly, and then there is a pair for testing XML disassembly and assembly. So like I say, these tools simulate the pipeline environment, but they can help you speed up testing iterations while you're editing your schemas. And then once you see that you're getting the output you expect from these tools, then you can move your testing out to the BizTalk runtime environment. In this demonstration, I will show you how to create a new receive pipeline and add components to it and start configuring those components. And I'll do the same thing with the send pipeline. And then I'll also show you how to use the command line tools to test your disassembly schemas. Okay, we're back in Visual Studio with the messaging project open. And I'll start off the demo by adding a receive pipeline to the project. Now I'll choose the receive pipeline item. And this pipeline will be processing purchase order messages. So I'll name it the receive purchase orders pipeline. And that will have the BTP or BizTalk pipeline extension. Okay, so we're in the pipeline designer, and you can see the stages laid out here. The first component in the decode stage is going to see the raw bytes that the adapter reads in and passes to it. And this is where we could add the MIME SMIME decoder. So I'm going to go find that in the toolbox and add it here. Now, in spite of the name, this component does allow us to decrypt messages that are not in MIME format. So I'm going to set a property on this component to enable that behavior. And that would be the allow non-MIME message property. Okay, that looks good. Let's go back to the pipeline and set up the disassemble stage. Okay, you'll notice that the connector here is set up a little bit differently, and that's because this is the stage that executes in first match mode. So we can add multiple disassembler components here, and at runtime, the pipeline manager will give the first component a chance to inspect the message and decide whether or not it can process it. And if not, pass it on down the line until some component does indicate that it can process the message. And by the way, we can leave any of these stages blank. So I am going to add two components to this stage. I'm going to add the XML disassembler first, followed by the flat file disassembler. So let's go find those in the toolbox. Okay, so if we get an XML message, the XML disassembler will discover that and process it. Otherwise, the flat file disassembler will get a chance to parse that data. So there's actually no additional configuration that we need to do for the XML disassembler. It will automatically look up the schema for the message that it receives, and it will read all of the instructions that it needs from the schema. And that includes property promotion, as well as disassembly instructions. The flat file disassembler, however, will always need to be configured with a set of schemas. So let's configure those now. Since we expect to be receiving sales order flat files, we need to configure the document schema property to point to that sales order flat file schema. In this case, we can ignore the header and trailer schemas since our flat files won't contain any records of those types. Okay, so here's the sales order flat file schema in the list. Now, the disassembler components won't validate these messages for us. So if we do want to perform validation, we need to add the XML validator component here. Okay, so we specifically want to validate the flat file messages, so we need to configure this component with the schema for those messages. And so we'll configure that through the document schemas property. Okay, there's the sales order flat file. All right, so that's 3 of the 4 stages complete. Now we can go configure the last stage, which is the resolve party stage. Okay, now if we want to identify the sender of this message, whether we're going to accept a Windows username from IIS and allow the resolve party component to perform a lookup against the list of IDs that we have configured in our list of parties, or whether it's going to use a certificate to determine the party that is sending this message. Either way, by adding the party resolution component here, we can rely on it to take care of that for us automatically. If it can make the determination, it will set the source property on the message, and if not, it will just leave that property blank. So let's go find the resolve party component in the toolbox. Okay, our receive pipeline is complete. So this will be able to take care of pre-processing on inbound messages. Now let's go create a send pipeline to handle post-processing on outbound messages. And as before, I'm going to add a new item to the messaging project. And then choose Send Pipeline from the list. And this is going to transmit processed order messages. So we'll call this the Send Processed Orders pipeline. All right, so here we have the pipeline designer, and the send pipeline only has 3 stages. First stage being the pre-assemble stage, and this really just provides a spot in which we can add custom components that need to execute before the assemble stage. But we don't have any of those, so we'll leave this blank. Now we expect that we will be modifying the values of some message context properties, and we want those values to be inserted back into the message as it's being sent out. So we'll depend on the XML assembler component to handle that for us. Let's go find that in the toolbox and add it here. And just like the XML disassembler component, there really is no configuration we need to do to handle that property demotion. We're going to assume that we need to encrypt these messages on the way out. Let's add the MIME SMIME decoder here. Alright, there actually isn't any configuration we need to perform here. We will need to configure a digital certificate if we want to perform this encryption. I won't do that in the demo, but you will get a chance to walk through those steps to configure that in the lab. So let's save these changes to our pipelines. So here is the format of the message that the XML disassembler will be receiving. We want the XML disassembler component to extract each of those item nodes and publish them as individual messages to the message box. Now, let's take a look at the envelope schema for this items list. Okay, you can see that the items element has a child of any. So that's indicating that the items node could contain children of many different types of elements. But ultimately, the disassembler is simply going to treat each of those elements as a new message. Also notice in the center pane that the body XPath property is included as an annotation, and that instructs the XML disassembler where to look for the child messages. Now, in spite of the fact that the envelope schema doesn't define the types of elements that the items list can contain, we do need to provide a schema for the types of items that we expect to receive. I'm going to use one of the command line tools to test the XML disassembly. So let's go launch the command window. And I'm going to add the path to the pipeline tools folder to the environment variable for this command prompt. Okay, now I'm going to change to the directory where the schemas exist. Okay, now we're ready to run the XML disassembler tool. But this tool doesn't have access to the BizTalk management database, so we need to provide the names of the schemas that we want it to test. Okay, that's the name of the file that contains our test data. Now we need to provide it with the name of the document schema. And then we need to provide it with the name of the envelope schema. And then I'd like the tool to write the output to the console. Okay, it looks like I have a typo. I can see that I spelled the name of the document schema incorrectly. Okay, the disassembler ran. We can see the output. And we can see that it found all 4 of the child nodes. So you'll be able to get a chance to try this out in the lab, and then you'll be able to deploy it out to the runtime and actually see it perform. In this lab, you will be creating a new send pipeline, and you will add the XML assembler component to it and the SMIME encoder. You actually don't really need the XML assembler yet, but you'll be using it in the next module. And then you'll deploy the send pipeline out to the runtime environment, and you'll configure a send port to use it. And then you'll need to configure the digital certificates that will be used to perform the encryption. And then once you have everything configured, you'll send a message through and verify that the encryption worked. After that, you will create a new receive pipeline and you will configure it to perform disassembly. And then finally, you will enable recoverable interchange and see how that affects the pipeline processing.